Now look at the fourth row, first field, which is header length. So header length is actually 4 bits is given there, but then we have seen that TCP header is minimum header length is 20 and maximum header length is 60, right? So it is same as IP header. IP header is also 20 to 60 and TCP header is also 20 to 60, and at IP header also we had only 4 bits. Here also we have only 4 bits. With 4 bits, how big number can we represent? With 4 bits, the largest number which I can represent is 15. So in a field which can hold only 15, I should represent a number which is as big as 60. So the same problem has arrived even at IP also, right? Then what did we do there? 60 divided by 15, we used a scaling factor of 4, which means whatever is the actual header length, we divided with 4 and we kept it in the field. So same things are applied here. So whatever we did there, the same thing here. So I'm not going to discuss it about it again. But now we shall see a problem using this. Let us assume that there is a field. If you look at the third field, it is called acknowledgment number, and I told you that acknowledgment number is sequence number of the byte expected next. So it is worth writing these two. So sequence number field is sequence number of first byte in this segment. So first byte sequence number is the sequence number field, and acknowledgement number is sequence number expected next, sequence number of byte expected next, right? So these are the two definitions. Now what do you understand from the acknowledgement number? It is always the sequence number that the receiver is expecting next from the destination, sender, right? So assume that this sender is sending we have already seen it, this kind of problem previously, but again I am doing it. So let us assume that there is a TCP segment, and this is the segment header, and these are the bytes, okay? And the first byte sequence number is 100 and the last byte sequence number is, assume that it is 150, right? And now or I don't know what is the last byte sequence number, I don't know what it is. Now this is what this sequence number of the first byte will be present in the header. So header contains sequence number 100, which means the first byte sequence number is 100. And now when this segment is sent, the destination has to send you the acknowledgement. What will be the acknowledgement number the destination will send? That is the question. So in order to find out the next byte expected, the destination should know what is the sequence number of the last byte. But the problem is, in TCP header, if you look at the TCP header, just open the TCP header and have a look at it, there is nothing called as total length. So we know the header length, but then we don't know the total length. Therefore, and there is a field called as header length. Therefore, we can know the exact header length of the TCP segment, but we cannot know the total length of the TCP segment. Unless we know the total length of the TCP segment, we cannot guess what is the last byte sequence number. That is a problem there, right? So what we could do is, we are taking the help from IP datagram. Every TCP header, every TCP segment will always go inside a IP datagram. So IP datagram is going to have a header, and IP datagram is going to have header length as well as total length field. Now what I do is, I take the total length field of the IP header, IP datagram, and from that I will remove the header length field of the IP datagram. Then I get the body size of the IP, and in that body size of the IP, that is nothing but the TCP segment size, I remove the TCP header size. Then I get the body size of the TCP segment. Now in that already the first byte sequence number is known, then I can calculate the last byte sequence number, right? So depending on that, let's see one problem here. Let us assume that the total length and header length, of a IP datagram are, total length is, let us say, 1000 bytes, and the header length is, let us say, 5. These are given for a IP datagram. The question is like this: the total length and header length of IP datagram are like this, and inside IP datagram there is a TCP segment, and the header length of the TCP segment is 5 and the sequence number of the TCP segment is 100. This is the present, this TCP segment is present in this IP datagram. Okay, so what is it? The IP datagram is containing inside it a TCP segment, and IP datagram total length is this and header length is this, and TCP segment total length is this and header length is this. Now using this, I want you to find out what should be the acknowledgement number for this packet. Acknowledgement number means what is the sequence number of the byte expected next. How can you do it? Watch it once. Now let us say there is a IP datagram. Inside that IP datagram there is a TCP segment, and I am saying that the total size of the IP datagram, the total length is 1000 bytes and the header length is 5. So header length is 5 means, what do you mean by that? Header length is 5. Can header length be 5? Actually the minimum header size possible is 20, and from 20 to 60 is the header length size, but then here they are saying that it is 5. So what do they really mean is the scaled down version. So whenever the number is less than 20, always multiply with 4. The reason is minimum header size should be 20. If it is less than 20, they mean to say that it is a scaled down version. Then what is it? 20 bytes. So header length of IP header is 20 and total length is 1000. Therefore what is the body length? You could guess. The body length is obviously 1000, which means 980. 980 bytes is the body length, right? And now they are saying that TCP header length is, this TCP header length of the TCP segment is again 5, which means 20 bytes here, right? Now this is 20, this is 20. Therefore what is the body length of this? 960. So how many bytes of data are present? So inside this TCP 960 bytes are present, and then they are saying that sequence number of the TCP segment is 100 bytes, which means the first byte sequence number is already given as 100. Then what is the last byte sequence number? That is what they are asking. The total number of data bytes present in this is 960 and the first one is 100. Therefore what is the last byte sequence number? Last byte sequence number is 100 plus 960 minus 1. This is the last byte sequence number, right? So why minus 1? You can guess it. So if I have 10 numbers and the first number is 0, then what is the last number? 0 plus 10 minus 1, isn't it? Similarly, I have 960 numbers and the first number is 100, then what is the last number? 100 plus 960 minus 1. Similarly, if I have, just like this, if I have 10 numbers and if the first number is 0, then what is the 10th number, the last number? 0 plus 10 minus 1, which is nothing but 9. So that is how I got this. The first byte sequence number is 100. Then in order to guess the last byte sequence number, the total number of bytes is 960. Therefore 100 plus 960 minus 1. Then how much is that? 100 plus 9, this is 1059. So 1059 is the sequence number of the last byte. Then what is the acknowledgement for this segment? So if you have received from 100 to 1059 bytes, then what is the next byte that you are expecting? 1060, right? So this is the answer. How did I get it? If I got already the sequence numbers from 100 to 1059, then what is the next byte sequence number I should expect? 1060. So that is how the receiver will calculate the acknowledgement number, right? So given these parameters, now how will the transport layer get these parameters? Obviously transport layer can communicate with the network layer which is present in the same host. Always remember, at transport layer it can communicate with network layer as well as data link layer. There are already interfaces defined. So at every computer, every layer will communicate with the other layer if that layer exists, right? At routers, if transport layer doesn't exist, it cannot communicate, network layer cannot communicate with transport layer. But any layer which is upper, which means any layer which is above, can communicate with the layer which is below, right? Therefore transport layer, whenever it gets any packet, it will even ask the network layer to send the details from the IP datagram. From that it is going to compute how much data is present and what is the last byte sequence number and what should be the acknowledgement number. Okay.